Greetings. Welcome to week 7 of our online learning. So for this week, we're going to be talking about the addition rule of probability. So it's going to be a more in-depth and general understanding of probability. Right? We're going to go over that later. First, before we go to the lesson, we need to actually go over the guidelines for online safety and responsible use. Right. So please be reminded that the PGCPS administrative procedures regarding appropriate use of technology, social media, and email continue to apply to our online instruction. In addition, this session may not be recorded without the instructor's consent. A description of the applicable procedures is provided online in the Student Rights and Responsibilities Handbook. Thank you for your cooperation. Right. So in this particular, I'm sorry. In this particular context, this phrase or this statement is to be construed as this recording cannot be shared without the consent of mine. So if you would like to share it with somebody you know who you think might benefit from viewing it, please let me know so I can definitely issue you with written permission. Also, if you would like to read more about online safety and responsible use, you of course may do that by going to the PG portal and looking for the student handbook, or you could just go to our Google Classroom, go scroll all the way down to the earliest parts, and then you will see a link there that brings you to Student Rights and Responsibilities Handbook. Okay, now that this online safety is out of the way, we can now actually proceed with our lesson. Oh, by the way, happy Memorial Day, right? For those of you who actually are excited about Memorial Day. Okay, so today we're going to talk about addition rule of probability. Okay, so it's also going to include what we call independent and dependent events. Right. So objectives for this lesson. So we are to differentiate independent and dependent events through numerical proof and solve probability word problems considering independence or dependence of events. Okay, so although the lesson proceeds from addition rule of probability, eventually the more important content will be found at the end, which is of course independent and dependent events. Okay, so review or preview of the lesson. So probability is defined as the ratio of the number of desired outcomes with the total number of possible outcomes. So this can be expressed mathematically as the probability of A as the number of ways that A happens divided by the number of ways that everything can happen. So in this particular lesson, we will focus on probability as more of chance rather than based entirely on counted outcomes. Okay, because sometimes it is impossible to quantify how many ways a particular event happens and how many possible events can happen. So we are more going to consider probability for this particular week's lesson as chances rather than as actual counted scenarios. Okay, so the addition rule of probability. So the probability of events A or B happening or both, right? So take note, it's not an exclusive or. It's one or the other or both of them happening. So the probability of A union B, okay, which means either A happens or B happens or both of them happen, is equal to the probability of A plus the probability of B minus the probability of A intersection B. Now, the probability of A intersection B is the probability that both A and B happen. So the reason we actually have to subtract the probability of A and B happening together is that this probability has actually been considered twice. Once in probability of A and another on probability of B. Because take note, this is the probability that A and B happen. So therefore, it could happen in A and it could also happen in B, in which case you counted it more than once. So thus, we need to subtract that probability to correct the expression. Okay. Note that if events A and B are mutually exclusive, then the probability that A and B happens together, so intersection means that they happen together, is equal to 0. Remember, mutually exclusive means the events cannot happen together, right? As opposed to non-mutually exclusive. Right? So this was discussed like way back. Right, so if you would like to actually review on that, please do so. Go over to the previous videos so that you can actually review on them. All right, so this one is a Venn diagram illustration of the addition rule. Because sometimes it's quite helpful if it's through a Venn diagram. All right, so we have two events, A and event B. So A is this event, this circle right here, and event B is this circle right here. So this part of the circle, you know, which is away from the overlap part, all right, is the probability that only event A happens. This part here, the part of B, where it is, of course, away from the overlap part, is, of course, the probability that only event B happens. Then together, the two circles together, so this part, which is exclusively A, this part, which is the overlap, or what's common for both A and B, and this part, where it's only exclusively B, is the whole either event A or B or both happen. Okay, so this is the union. This three regions, exclusive A and B, exclusive B. That is A union B. This part, outside the two circles, but inside the rectangle, right, is the probability that neither event A nor B happen. Okay, so it's similar to actually when we were talking about Venn diagrams. But in this case, we're now just going to like look over chances. So take note, because the sum of all probabilities is equal to 1 for a particular scenario. Okay, so therefore, the total probability inside the rectangle should add up to 1. So if I write down individual numbers here, if I add them all up, it should all equal to 1. So here we have a particular example. All right. So in this example, there is a 70% chance that Jack will do his math homework and an 80% chance he will do his English homework. If there is a 60% chance that he will do both homeworks, what is the probability that A, he does either homework or both? Letter B, he only does his math homework. And letter C, he does neither homework. All right. Okay, so if you would like to actually try this out on your own, you may, of course, do so. You may pause the video to give you more time. And then when you're ready, you may unpause the video and then check your answers by looking over our solution. All right. I think that should have been enough time for you guys to have paused the video, try your best, and then unpause the video to actually check your answer. Okay, so before we actually go over the solution for this one, let's go to our whiteboard. Ah, to actually see. Okay, so if you actually look over the notes that will come with this video lesson, you would notice that the notes actually does not have a Venn diagram solution. The reason for that is I did not want to make the notes too long, because drawing Venn diagrams every slide is actually going to take a while. So I just put in there written notes, but definitely here in the video, I will go over the solution in terms of Venn diagram. Okay, so let's say the probability if A is actually for math, right? So it's math homework. And for B, it's actually the English homework. Right. So now we're supposed to figure out, I think for letter A, we're supposed to figure out the probability he does either homework. Okay. So the first thing we have to do is to actually fill in this Venn diagram with the correct numbers or with the correct probabilities. Okay. So first up, we always start with the overlap part, this one, which is of course the probability that both A and B happen. So the probability that he does both math and English homework is 60%, as mentioned earlier. So this one is 60%. So we can leave it as 0.60, as it is 60%. Okay. So now that we have that, okay, we are now ready to actually evaluate what is the probability of him doing only math, exclusively math, or the probability of him doing exclusively English. Okay, so the probability of doing math is 70%. Okay, the probability of him doing English and math is 60%. So thus, the probability of him doing only math is 70% minus the 60%, right? Because out of the 70%, 60% is actually him doing the math along with the English. So if you only want to focus on the math part, there is actually a 10% chance that he does only his math homework. Right? Now for English, we do the same process. So the probability of him doing English is 80%. And then we subtract the probability that he does also his math homework, which is 60%. All right, so there is a 20% chance that he actually does only his English homework. All right, okay. So now that we have 10% to doing only math homework, 60% to doing both homeworks, 20% to do only English homework. Okay, what's the probability he actually does neither of the homework? The question is like, what is the probability here outside the two circles? So take note, to be able to solve this one, I think that's too small of a space. So I'm just gonna like remove that. Okay, so to be able to determine that, remember, the sum of all probabilities in a particular scenario is 1. So therefore, if we subtract these probabilities, we actually end up with the probability him doing neither of the two homeworks. So 1 minus him doing math only, minus him doing both math and English, and minus him doing only English. All right, so 1 minus 10%, that's 90%, minus 60%, that's 30%, minus 20%, that is only 10%. All right. So in this particular case, all right, him doing math only is 10%, both 60, English only is 20%, and not doing anything is 10%. So let us now try to answer the questions. So the first question was, all right, both, sorry, not both. The first question was either math or English or both. Okay, so in this case, that is simply the sum of these three, which is 90%. The second one is the probability that he does only math. Okay, so for math homework only, this is just this particular part, which is 10%. And then finally, he does neither homework. That is simply this particular part, the one outside. So neither homework. That is, of course, 10% as well. All right. So this should be the answer. This should be the answers that we should be seeing onto our lecture. Let's check them out, see if it is correct. So, all right. So the first part is 90%. Okay, that he does either math or English or both. Okay, this one, when he does only math, it's 10%, right? And then finally, him doing neither homework is also 10%, right? Which matches the answers we got when we actually drew a Venn diagram. All right, so I hope you got those two as well. Right, so now let's move on to the next lesson. All right, so the focus of our objectives, independence and dependence of events. All right, so two events, A and B, are said to be independent if the occurrence of one of the events does not affect the probability of the other event. Thus, for independent events, the probability that both events occur is the probability A and B occur is equal to probability of A times the probability of B. So for independent events, you can simply get, you can compute for the probability that both happens by just multiplying their individual probabilities. All right, if the probability of both of them happening is not equal to the product, the two events are said to be dependent, which means that one factor affects the other. Okay, in this regard, we can see that mutually exclusive events are dependent events because the product is not equal to zero, although each event would have, okay, of course, a particular number, right? Okay, so the product is, the probability that both of them happens at the same time is, of course, zero because they cannot happen together. And this is, of course, a very good example of why they are dependent events. One happens, the other does not happen. Okay, all right. So this time, all right, it's same question. Okay, 70% chance that Jack will do his math homework, 80% chance that he will do his English homework. Okay, but this time we are also given the fact that doing each homework is independent of the other. Okay, so that means if he does his math homework, it's independent of him doing also the English homework. The two probabilities do not affect each other. So we have also the same set of questions. So the question is, do we actually get the same set of answers? Right? Let's try to see. Okay, if you would like to work this out on your own, you may, of course, pause the video first. And then when you're ready, you can unpause the video and then check your answers. All right, I think that's enough. That's enough already. All right, I think you're now ready to actually go over the solution and check your answers. All right, let's switch to our whiteboard and then discuss the solution and answers. Okay, so in this case, again, we have two probabilities. All right, math homework is A, English homework is B. Right, so it's mentioned that the probability of A is again 70%. The probability of B is 80%. Okay, it is also said that A and B are independent. Okay, so the thing with this one is, if we are going to actually try and solve this, like how we solved this before, we actually need the common part first. We actually need to determine this one. It's not actually given here. We're only given the total probability for A, which is this whole circle here. And we're given the total probability of B, which is that whole circle there. So the question is, what is the probability that both A and B happen? All right. So the probability that both A and B happen is equal to the product of the probability of A times the product of the probability of B. Take note, this one will work because they are said to be independent, right? Which means that the probability that both of them occur would just be the product of each of them occurring. So we have 70% for A, 80% for B. You get a 56% chance that he actually does both homework. All right. So now that we have what is in the middle, we are now ready to actually answer or actually proceed outwards. What is the probability that he only does his math homework? So that is simply 70% minus 56%, which is 14%. What's the probability of him only doing English homework? That is 80% minus 56%. So this is 24%. All right. Okay. So now that we have that, okay, what's the probability of him doing neither homework? So to do neither, that would just be 1 minus 0.14 minus 0.56 and minus 0.24. All right, so what would be the answer for that long subtraction thing? So 1 minus 14% is 86%, minus 56%, that's 30%, minus 24%, that is 6%. So therefore, the probability of him not doing any of the two homeworks is only 6%. So now we are ready for our answers. The probability of him doing doing either homework or both is actually 14% plus 56% plus 24%. This is 94% chance. B, the probability of him doing only the math homework. This is simply 14%. And letter C, the probability of him doing neither of the two homeworks is simply 6%. All right, so notice how it became different from the previous one just because of one particular expression, independent. Right, so take note, when you say two events are independent, the probability of them occurring together should just be the product of their individual probabilities. Okay, let's go back. Check our answers. Okay, so here we go. We got the 56% chance for him to do both homeworks. 94% to do both to do either homework or both. 14% just to do math, and 6% to do neither homework. All right, I think after this slide, we actually have just one last example. Okay, so an urn contains 5 blue balls and 3 red balls. Suppose 2 blue balls are to be drawn. Determine whether the drawing of the 2 balls is independent or dependent of each other if, letter A, they are to be drawn without replacement, and letter B, they are to be drawn without replacement. All right, so, okay, so the question is, okay, determine whether the probabilities are independent of each other if it's to be drawn with replacement, or if it's dependent or independent if they are to be drawn without replacement. Okay, so if you would like to try this out on your own, you may do so. You may pause the video, try to figure out whether it's dependent or independent, and then when you're ready, you may unpause the video and then look over the answers. All right. I think that should have been enough time for you guys to have paused the video, make a decent attempt, and then unpause the video to actually come back here and then check whether you got the right answer or not. So we're going to our whiteboard again. Okay, so in the particular urn, you actually have 8 balls. 5 of them are blue, 3 are red. And then you're supposed to draw 2 balls. Okay, so the question is whether it's an independent or dependent event if you draw with replacement and if you draw without replacement. So let's focus on the first question first. Drawing with replacement. So with replacement, right, the probability of the first draw is simply 5 out of 8, right? Which is logical. Okay, because there are 5 blue balls and you're supposed to draw 1. Okay, so that's a 5 out of 8 chance of getting a blue ball. Now, because this is with replacement, after you draw the blue ball, you return the blue ball. Right? And maybe you shake it a bit, and then you draw again. Right? So to get a second blue ball, that would be again a 5 out of 8 chance. All right. So therefore, the probability, right, that you actually get 2 blue balls, right, in that 2 draws is simply 5 times 5, that's 25. 8 times 8, that's 64. 25 over 64. So notice, this type of event is independent. Okay, because this probability, right, was not affected by that one. All right, it was still the same probability. Now, consider a scenario wherein it's without replacement. Okay. All right. So for without replacement, I actually saw a lot of you answering this way in the previous exercise. That's great. That's very good. So without replacement, the probability for the first draw is 5 over 8. Okay. All right, draw is a 5 out of 8 chance you get a blue ball. Check it. Okay, it's blue. Okay, then what happens? Okay, so what happens next is that you don't put the blue ball back onto the urn. You actually set it aside because this is a without replacement problem. Okay, so what happens now is that the urn would contain 7 balls because you already took 1 out. And then out of those 7 balls, only 4 are blue. So thus, the probability of the second blue ball okay, is 4 out of 7. And then, of course, you're going to multiply this. Right? So 4 and 8, they cancel each other out. That's 1/2. So this is simply 5 over 14. All right? So notice how this probability is different from the previous one. Okay, so this happens because the probability here changed because there was no replacement. So therefore, drawing without replacement are dependent events. Okay, because the probability has changed, right? It's different from multiplying the individual probabilities if you were drawing as if there was replacement. Okay, so how do we even know whether this probability is correct? We can actually check that by applying a different technique using counting technique. All right. So take note, we're supposed to draw 2 balls from the urn, and what we want is actually for those 2 balls to be both blue. So therefore, the probability of drawing 2 blue balls, all right, would be first the number of ways how we can get blue balls. So that would be combination from the 5 blue balls, you choose 2 blue balls. All right. And then what are the total number of possible outcomes? Okay, that's, oops. Out of the 8 balls, you choose any 2 balls. All right. So if we simplify this, 5 chose a combination of 5 taken 2 is, what is it, 10. All right. And 8, combination 8 taken 2 is, I think, 28. Right? You may, of course, check that with calculators. So if you reduce 10 over 20, this is also 5 over 14, which matches our answer from earlier. All right. So this is how you actually check whether the 2 events are independent or dependent of each other. You check whether the probability of each of them is affected by the other. All right. So I hope this lesson has been quite clear. Oh, wait, let's just check whether the answers were correct. We're just going over to the... All right. So the first one is 25 over 64, 39%, independent. All right. And then the other one is 36% chance. Actually got smaller, huh? Yes, okay, got smaller, okay. All right, so I hope this lesson, all right, was quite clear to you guys. If you have more questions about this, of course, you are free to always post on our weekly Google Docs. All right, that's all for this week. So I hope you guys stay safe. All right, we'll see you next week. Bye.